Always get it there, hopefully. Okay. All right, thanks you guys for having me here. It's great to be here in person and see all you and everyone on Zoom. Thanks for coming. Yeah, so let's see. All right, good. So let's talk a little bit about data. Okay, so there's a lot of data every day. We have more and more data. All these different kinds of learning systems that we're using are producing lots and lots of data. What I want to take maybe like 10, 20 seconds, think about right now, all the data that's being collected right now. Any ideas? What do you guys think is being collected right now?
Data on Zoom.
Zoom, like what kind of data on Zoom?
Well, your audio, I guess. Well, I guess your text information with the messages still.
The chat, this is the text
Yeah.
coming in the chat, there's
The
audio coming in
streams,
Zoom.
Yeah, the video stream.
Yeah.
And then your phone.
Uh-huh.
You know, what, I don't know, like your track, if you have mobile location tracking on.
Right,
Yeah.
okay, location tracking, sure.
There's a ticket open somewhere for this room because ETS came in.
Connected to internet, IP addresses.
IP addresses.
Metadata.
Yeah, people are getting emails probably right now. It's fine. Anything else?
My Apple Tag knows my keys are here.
Your AirTag is sending messages to all the other Apple devices in the room. Yeah.
That's scary now.
Like subtle, small messages. It's not like that bad. Okay, so there's lots and lots of data, and I want to think also specifically about a situation where we have maybe 3 students working in a small group. They have a shared device. There's lots of inputs. This is one of the things we'll talk about later today. It's produced lots and lots of data. Look, this is actual data from that particular project. This is some log data, but there's lots of data just constantly being produced all the time. And I want people to just think a little bit more about what that data looks like and how we are thinking about how to think about that data, actually. So some of these questions I want you guys to think about today are sort of like, what other types of data are available in a learning setting? So this is a learning setting. There's a lot of data we talked just about right now that maybe you hadn't thought about before as data that could be collected or is being collected by other people. What is being done with all that data? What can that data say about learning, if anything, or teaching or things like that? And does the type of data we collect change how we're thinking about learning or teaching? Are these different constructs we're interested in? Does the type of data we have, the modality of that data, make any difference in how we're thinking about what that construct is? And then kind of, you know, further along the line of like, how can we help teachers or instructors or learners improve using that data? So that's kind of the themes for today. Okay, so it's sort of an overview of what I'll be talking about today. So kind of a little bit about why we need to think a little bit more carefully about this data, how to move from just having more and more data to having better data and what that looks like. I'm going to give a couple examples of what I think are sort of better data in different kinds of realistic settings. Sorry, my pancreas is beeping. That's good. Okay. So there's a couple of projects I'll talk about. One is this speech-based learning analytics for collaboration. Another is I'll talk a little bit about these adaptive dashboards that we prototyped, and then some current projects that involve different kinds of data, one around med school students and another with high school math classrooms. Okay, if anyone has any clarification questions as we're going through, please interrupt me and ask me, and then we can save kind of more substantial questions for the end. Okay, so thinking first about like what data are being collected. So I like to think a lot about like realistic settings, so like a real classroom setting, not as much kind of a lab setting. A lot of learning happening nowadays is happening in these blended environments. We have one right now. We have sort of a hybrid system. Some people are here in person, some people are online. A lot of people are on their computers interacting with different things on their computers. So there's this physical setting that we're in, and then there's also a lot of digital kinds of settings that we're in as well. And there's all these digital platforms that we might be interacting with in physical settings that are also collecting and producing data. Now, as you might imagine, it's relatively easy to collect data from these digital systems, right? Like it might automatically get logged or other things like that. The physical settings have a lot of other things. Like I think nobody mentioned, like me talking right now is sort of data that's happening this right now in this setting. Like you guys are all sitting, like there's information kind of like where people are sitting. No one's sitting back there, no one's sitting here. There's other things going on. People are looking at each other. There's a lot of gaze that's happening sort of in the physical setting. That's also data that we should think about. And then I just want to sort of contextualize things like, I think everyone here probably understands learning systems there's ecosystem, right? There's all these different interacting sections, the student, the teacher, the content, they're all interacting with each other, all happening within a situated environment of the classroom that all has these different kinds of external things. There's an environment, like you can't sort of take these accountability demands and the PD available to these things outside of, they're all related, it's all part of a system and they relate to each other in important ways. So we want to make sure we always are thinking about all those things. Okay, so from more and more data to better data. So the data that are coming out of these systems, right, are the data, but also the system itself, the data system we've created is also kind of an important thing to think about. And I showed you that screen about that raw data. Is it really raw data? I don't know. Like we can't really, it's never really raw data. Like I decided what those columns should look like and how often it should be collecting these things. And like the person decided those things, we can't forget that. But also that raw data is basically useless in its current form, right? We have to do things with it. So, whenever you're doing any kind of analytics thing, like this data cleaning process, data management, that's really important part of the whole process. And if you don't have the right raw data in the beginning to start with, there's not too much you can do to massage it into the right data later on. So you need to think very carefully at the very beginning when you're planning data collection, when you're planning everything, when you're planning your data system, what data are you collecting, how you're collecting them, what's the right grain size, those data, all these different things. Those are the really important decisions to make as early on as possible so that you're able to do the right things you want to do later. And if we have these blended learning scenarios, like how these data relate to each other. So we have data coming out of a digital system and we have data coming from the physical setup, like how those can talk to each other, how they relate to each other, different grain sizes, different levels of data, like all those things matter as early on as possible. Okay, so I want people to think about, what you can do to design those data systems. Yep, yeah, it'll come back. So, one of the things that, see, magic. So these different digital learning systems are usually designed to prioritize a certain feature of the system. And if you are not there, you as a researcher are not there early on to help guide what that data that's being collected can be a real problem. And I want to show you a picture, but it's, so one thing to think about is, so this is an example from, this is like SimCity EDU. It was a game, it was using the SimCity engine to sort of create these learning activities, and the people who designed it didn't talk to the education people early on enough, and they weren't really thinking about things. So the system was set up to collect when people clicked on things in the game, which from a game designer perspective makes sense. And that's, kind of was the basic way of doing things. And yeah, the click gave us some information. It told us when students had made a decision about something. They're like, okay, I've decided I'm going to do this thing, and that's fine. But the problem is we were trying to study learning that was happening. We wanted to see the process that was going on. And when we watch kids play this game, we're like, well, they're hovering over a lot of things. They're hovering over this. They're like, oh, this is, there's some data associated with these different buildings and they can think about these pros and cons of different things. But the hover had all the information we really wanted about learning, but none of that was being collected. Only the final click, the decision they made, which is not nothing, but it wasn't really what we had really wanted. So, thinking about these kinds of things and how we can, or as early on as possible, try to intervene so that okay, we want to know, we want the hover data collected. We could log that, it wasn't logged. Okay, so I want to talk a little bit about collaboration now. So it's a specific project. So I think everyone is familiar with collaboration. It's a really important 21st century skill. Also, like, students do not come to school knowing how to collaborate. It's not like some obvious thing that people know. They need practice, they need targeted feedback in order to improve, just like any other skill. Like, they need to be able to practice it and get better and get feedback and that kind of thing. However, like, providing that feedback is very difficult for instructors to do, right? And so you can think about a teacher, we have students, so we have like maybe 30 students and one teacher, and we have 10 groups of students. Like, it's literally impossible for that teacher to monitor all those groups at the same time and like find out what's going on with their collaboration. Like, they just physically can't do it. We would have to clone the teacher and have 10 of them, all of them looking over their students' shoulders while they're doing things. And like, obviously that's not possible, though I don't want it. Okay, so there's a couple possible solutions to this. And probably the one that's been done the most frequently is to ask students to type to each other while they're working on these things. And that's fine, especially if the students are not co-located together. Like, typing might make a lot of sense for them, and that's totally fine. I would argue that changes the nature of the collaboration, especially if they're in a face-to-face situation. Like, I've been in schools where they're like, please, like, type to each other. The kids are like, they're sitting right there. Like, why can't I talk to them? Like, we need the data, so like, please type to them. And but you can collect a lot of data that way, and like, the text data is pretty easy compared to other things to analyze. Like, you have, it's pretty rich data set, it's not too bad. But, you know, I don't think it's the best, right? So one better way possibly is to collect the audio data from that and do some kind of speech analysis. So, you know, we're in a face-to-face situation. Speech is the normal kind of communication mode for things, especially if you're trying to collaborate. A lot of it is talking to each other. There's more nuances of communication that happen. It's less obtrusive in a lot of ways. And also it's closer to the information that teachers would want, because if you imagine yourself as a teacher, you're gonna like maybe like, you know, walk around, you're listening into their group and what they're saying to each other. You'll be attending to other sort of physical things that are happening as well, but a lot of it is captured in the audio. Okay. Of course, it's not super easy. There's a lot of challenges to this. So this a lot of times will require experts in a field outside of education. So in this case, we worked really closely with speech researchers to collect the right kind of audio data and analyze it and all those kinds of things. Collection of data in these physical spaces is very challenging. You also have to attend really carefully to these online data structures and how that works. And then, you know, trying to integrate the physical and digital data is non-trivial, to say the least. Analysis is usually more difficult, and it also probably requires multiple iterations of some kind of design-based implementation research, or like, try this out. It's like, okay, this didn't work for this reason, and we hadn't thought about that. And then you kind of can move on and iterate over that. So I'm going to talk a little bit about this project. It's called Speech-Based Learning Analytics for Collaboration. It finished up a few years ago. It's an NSF project that I led. We had an interdisciplinary team of learning scientists and speech researchers. We had 2 phases of data collection in middle school classrooms. And basically trying to think how feasible it is to use this speech data to really capture collaboration, like what that means. How well are they collaborating using this data? So I have like kind of a diagram to explain the research questions, but basically the thing is that we had sort of human coding of these different indicators and of the overall group collaboration quality. So we're trying to see how those relate to each other, as well as automatic. So they were extracting speech features and then how well those kind of led to the indicators and the collaboration quality overall. That was sort of the main idea. Okay. They look, oh, come on, Dan. So it looked like this. So we had 3 students. They're wearing these headset microphones. They had a shared iPad system, and then they had these little clickers, which were like a hacked Wiimote that we made. That was the way they interacted with the system. We were trying to constrain as much as we could around the activities to collect very specific data around this to sort of make the problem feasible. So the example items looked like this. Yep. So they had a series of about 12 questions. And so each of the 3 students had control over each of these little boxes. So they had a little scroll thing they could do. And then when all three people had decided that this was the right set of answers, then they all had to simultaneously push the button on their remote. So they had to talk to each other. Like these are not like the best items in general for like math learning, but like we wanted to make sure they had to talk to each other, had to collaborate in order to solve the problems and talk to each other because we needed the audio data. So it's just an example of one of those questions. And then this is what the setup looked like. So like I mentioned, physical data collection in classrooms is a mess of cords and things. So like imagine this times 10, which is what happened. So we have, you know, each of the headset mics had a cord on it. Each of the Wiimotes had a cord. There was an iPad, which was also plugged in. This was a camera with another group level microphone. And then power cords everywhere. It was chaos. Okay, so like I said, there was two phases of data collection. The first phase was kind of a lab setting. It was in a classroom, but it was like after school, so it wasn't kind of in a normal class setting. So we had a bunch of data from that, and then we had a second phase where we did it during a normal class period in a middle school math classroom, and so we have lots and lots of data. The first data set is like a release data set of kids talking about stuff. Okay, so what did it look like? So let's imagine one group, we have 3 different students that are all talking. So I'm just kind of talking through the coding that we did. So there was 2 levels of codes that we coded for manually by humans, and also we're trying to predict from the machine learning. So the Q code was sort of the quality of collaboration. So this was a group level code. It was coded every 30 seconds, as well as every item. So like I said, there were 12 items. Those were variable length. Some students took maybe like 1 or 2 minutes to solve them. Sometimes it took 10 minutes, partly depended on what grade level they were and other things that are happening in the world. So the Q code, the group level, and then we also had these I codes, which were individual indicators of collaborative behaviors. So there was a series of about 15 of them. Most of them were pretty sparse. So there's only a few that kind of happened, but they were things like, you know, are they asking questions? Are they monitoring the group progress? Are they verbalizing their thinking? Different things like that. Those were codes during the window when they were actually happening. So they were happening at variable lengths, and they were happening kind of whenever they were happening.
So you coded for the event when it happened, or
For the I codes, yes. Yeah, so it was coded just when it was occurring.
Going off that, are duration or just frequency of those?
The duration, yeah. So it kind of looked like this, where we were like, okay, this code starts here and stops here. Yeah. We had all that information. That's very important, as I'll talk about in a minute, yeah. Any other questions? All right, so we did that. We had to build some custom software to code that properly, because it turns out like nothing exists to make that work. This is some IRR, like a screenshot from an IRR we did. You can kind of see how things lined up across the different coders. Okay, and then on the speech side of things,
the software?
yeah. Nope, you can't have it, I'm sorry. So this is, so this project was when I was at SRI. Yeah. SRI is a nonprofit research institute, and they like to have proprietary software to give them a competitive advantage when they're writing proposals, because that's literally how they.
You're teasing these people.
I'm really sorry.
This is evil, but good
I
evil.
apologize.
Could you say that, what did it do that
Yeah.
was unique that others?
So we had like a video of the kids. There was multiple audio channels, and then we had multiple coding channels as well. And like we, at the time, this was a few years ago, there wasn't software that existed that would let us do that easily.
It's a more sophisticated version of Elon almost.
Yeah, kind of. We looked at some other options, but they just didn't do what we needed. So. Yeah, no, it's sad to me too. I think it's bad. Okay. And then on the speech side, so we're mostly focused on speech activity features. We also looked a little bit at prosodic features, but I'm not going to talk as much about that today. So in terms of the speech activity features, again, there was 3 channels, right? And so we were capturing sort of the amount of speech that was occurring on each of the channels. And so in addition to that, we also looked at sort of how much time was anyone talking? How much time was only one person talking? How much time was pairs 1 and 3 talking, or 1 and 2 talking, or all 3 of them, or nobody? We had all that information for the frequency and the duration of all those things. So there ended up being about 50 or so as like metrics based on the speech activity. So the analysis for this was like fairly complicated. Yes, so we're like looking at the I codes in different ways. Again, those are the individual indicators. We did a lot of normalization for the length of the item, as well as looking into the duration of the code. So for instance, like one of the codes is like verbalizing thinking. You might think, okay, so if someone codes that and it's like a really short, like, you know, really short one versus a very long code of verbalizing, those might mean something quite different. And so we felt like, okay, if we take the duration into account, put that in the mix, maybe that will help things, which spoiler, it did. So we had group level analysis. Again, we had those 30-second codes as well as the item code. So that was hilarious. And then we were trying to map the I codes onto that group level analysis in lots of different ways. It's not easy. Like I think like having it like, okay, see, like, we have this group and they have these individual codes, like that should be pretty straightforward. They're kind of like nested within each other, but like they're at different grain sizes. They mean different things. They have different kind of like ontologies to them. It's like really not straightforward to do that mapping. And then, you know, we had the hand code everything. So we were doing supervised machine learning to try to do that and do some random forests and basically trying to compare the speech activity and the product features, and which ones are really more predictive of the hand codes. Okay, so what did we find? Okay. So one of the things was that the group level codes had like 4 levels to them. It was anywhere between like they're not collaborating. There were sort of 2 middle codes that were like one person's like kind of trying to take over the group, or like 2 of the 3 people were working pretty well together but leaving out the other person, and then a code where it's like they were collaborating pretty well together. So when they were like not collaborating, they all looked pretty similar. Either they had like not very much talk going on in general, or they were off task. And so that was pretty much what we expected. And it was not too surprising. But what was surprising is that when they were collaborating well together, there was a huge variety of ways that looked. And that kind of surprised us. We were kind of expecting the quality of participation across 3 people to be more important. And definitely the groups that had equal participation, they typically were more likely to be collaborating well together, but it wasn't the only way they could be collaborating well together. So it wasn't necessary to have that, but it was definitely more likely. So there were some cases where you might imagine like one person's maybe not as talkative as other people in the group. And so, but they were still communicating. They were still like either non-verbally or doing other things to contribute to that group, doing a good job. And then I think the other important thing too is that the groups were not kind of like, we're good collaborators and we're bad collaborators. Like it varied and fluctuated quite a bit throughout the items and throughout within items, sometimes within a longer item. And so, you know, I think trying to, you know, really think about smaller amounts of time and trying to determine like, is this collaboration going well? Like things can be really good and then like drop off at the end for whatever reason because they're middle schoolers. So
Could you isolate what was making those times good or bad collaboration times? Was it, you know, if someone's not participating in X, Y, and Z, were they participating in A, B, and C because they were interested in something or because something was controversial, or?
There weren't really a lot of controversies in these math problems. I would say a lot of times they got off task because they were like, either they were just getting frustrated, the problem was too hard for them, which happens sometimes, or like they just were like, I don't want to do this. They were just like, you know, being middle schoolers, and that happens for sure. But I think there were other times where groups were like struggling a little bit, and so that sometimes that struggle kind of broke down their like good communication or things, but they were able to recover it later. And so it just kind of depends. There are definitely some groups that I'll show you in a minute where they just like were not, just like not doing it. The other groups, most of them were trying, giving it good faith effort. So here's an example of one group. So look at this beautiful diagram. I'll have some coffee. Okay, so each of these sort of rows, chunks is one of the items. This is 10 items for this one group. And each of these codes, and this is sort of across time. And so you can imagine what this looks like where we have things that are changing. Basically, the idea is that with even one item, like they're gonna change kind of every 30 seconds, we're like trying to measure how well they're collaborating with each other. And you can see that there is fluctuation across the different ones within the groups that are like doing pretty well. And then even over time, like they're gonna be doing a little better early on, and then they kind of fall apart towards the end. And that was pretty normal. So, so this one, okay, so every little box here is one group, and this is the whole data set. And so the way to look at this is each of these little bars here is one of the items going across. So you can see some groups just only did 3 items. Some of them had like technical problems. Some of them were just having a hard time. And then the colors here are representing how much talk was happening by each person in the group, and they're ordered by the most talkative. So you calculated the duration of talk for each person, and they were reordered. So the green is always the most talkative person in the group, orange is the second most talkative, and then the purple is the least talkative person in each group. So there's a few things that kind of want to point out here. So first, there's some groups that like just basically didn't talk very much. So you can see this example here, like this group was not a great collaborator. One person kind of took over most of the conversation and like overall just didn't talk very much. There's other groups here, you can see even less talk. There's some groups just, they don't talk. Other groups are talking quite a bit. Here's an example of a group that had quite a lot more talk, but also you can see, hopefully you can see, there's a lot of green, right? So this was really dominated by one person. Like one person did almost all the talking in this group. And these letters up here correspond to the group quality code. So the G is like good collaboration, and like, so you started off doing okay, and then it just like got worse. So F is like the second lowest one, right? So they didn't do very well. So that was kind of a problem for that group. And then there's other groups where they had sort of more equal participation across the group. Like this one had pretty equal, changed a lot, and like overall this group did really well, except for the very last item. But like overall it did really, really well. And so that's an example of like, they had pretty equal participation and also like had a good collaboration. There's other examples of that too, but we can spend the whole time just looking at that graph, I think. Okay, so in terms of the prediction for using the machine learning parts, the I-codes that included information about the length of the item and the duration of the I-codes performed a lot better than the other one. So, and I guess that makes sense. Like we're trying to keep it simpler, but it turned out like, oh, we need to put that extra information. Like I said, the duration of those codes does matter. And that even outperforms sort of just the speech activity by itself. So having the speech activity plus the I-code information was the sort of the best option that we had for doing the predictions for the group that was going on, which makes sense. Okay. All right, switching gears a little bit, I'll talk a little bit about adaptive dashboards for instructors. So a lot of times we have these dashboards dashboards are for the instructor, right? Rather than for like a researcher or even for students to come out. And so a lot of these instructors have different needs than you as a researcher might have or a student might have in terms of like what kind of data they need to look at, what kind of grain size they need to look at, and like what kind of context they need to kind of understand that, right? And so you need to sort of plan these data displays that are suited for their specific needs at the specific time that they need them at the right kind of level, right? So there's a lot of issues around timing, aggregation, and grain size need to be kind of taken into account. So we had this project that was around community college math instructors. They were using this curriculum that was sort of in a blended learning environment. So all the students came into class physically and then like signed into the computer, and the curriculum was all online. So we had a lot of data coming from the online system, but they were in person. Okay, so the idea behind this project was to create like an early warning system for the instructors if students were like in danger of dropping out or failing the class. Community college, these classes are notoriously difficult for some students, and they're a huge block for some students, so they can't pass them. So it's really important that we're trying to catch people as soon as possible that might be failing to help them with this thing. So we had a lot of historical data, and we found sort of a few variables that were really predictive of the failing rate in the course. So we're really excited about that. But then we also noticed, very importantly, that there was a lot of variability among the instructors and how they were using the course, how they're using the curriculum just at like a really basic level. So for instance, some instructors, they had this like quiz kind of thing built into the thing. Some of them assigned it as a required homework item, which is fine. And then some of them were like, it's optional, like don't worry about it. But like how students performed and how they behaved around that quiz item was like extremely important for the prediction algorithms and really trying to understand what was going on in the course. So we're like, oh, that's kind of an issue. We need to like really think about how to sort of contextualize that particular variable in general and like what was going on. So what we did, this is a prototype dashboard. It was never actually implemented, sad face. But the idea was, so basically you could select different weeks of the course and it would display this thing and basically tell you like, there was like an off track kind of indicator. And so if they're above a certain threshold or like, oh, these students, like you might say like students that have like a level 4 off track, like you might want to email them or do some kind of messaging around that. And so like whatever. But the thing is that there was these like 4 variables that were really important. And what we did was we created little checkboxes for them so that so everyone got the same kind of dashboard. But like if you're one of the teachers who's like these CPs, that was the quiz. So if you were one of the people who like assign these as an optional kind of thing, it was like you can do them or not, it's up to you. You might want to uncheck this box and not have this variable be part of the calculation for at-risk or at-risk, because when you're using the course, that doesn't make sense to have that as like a required thing. So kind of giving them options like this, like, and maybe it like has to do with which week it is too, so they could change the week. Like early on the course, maybe it's required, and later in the course, it's not required. This gives them the flexibility to decide when, for their particular context, what they know about how they're teaching this course, what's the right kind of set of things to do. And then we also gave them these different thresholds for the variables to decide, okay, like maybe this one's like really important, so I'm gonna like move it up, or like this one's less important, I'm gonna move it up. So just like give them some options of like, I don't want students logging in on the weekend, so I'm gonna change this, like it gives them more flexibility, or like there's a break coming up, so just change it, whatever. Like just giving them options and flexibility that are still aligned with what we kind of saw in the analytics.
So the days logged in, does it factor in, like sometimes you just leave the web page up?
Yeah, unfortunately, that happens.
Yeah.
Usually the case, but like, yeah, you could definitely do that. And then, that's why there's multiple variables, so that if you just leave it open all the time, that won't be the only thing. So if you like left open but didn't do anything, then like your like numbers of percent of resources access would be really low. So it's just an example of like ways to kind of think about better ways to act, like even if you didn't plan all of the data collected, like which in this case we did not decide what was logged by this curriculum, there are ways to kind of like find better ways to decide what's being viewed and give people more flexibility and agency on like how they're seeing that. Okay, I'm going to spend a little bit of time talking about current work, and then we'll have time for questions. So I want to acknowledge a few team members that are working with me on some of these things. A bunch of grad students, some of them new, and a couple other professors I'm working with. Okay. So I have one project, which is a collaboration with the medical school. We have a new medical school, is really excited. They do this problem-based learning and facilitation. I'll talk a little bit about that next. And then we also have this NSF project, which is basically trying to look at ways of combining what's called like computational grounded theory. But we have, ways of looking at qualitatively focused, like either grounded theory or other kind of qualitative kind of approaches to looking at audio-visual classroom data, as well as different kinds of computational techniques, so computer vision techniques, audio analysis, trying to kind of marry the best parts of those two things together. And so we have some things in progress. We have a website here if you want to kind of see some of the things we're doing. We're about halfway through this project right now. It's a methodology-focused project trying to produce kind of tools for researchers and guidelines for like how to do this kind of work. And then I have another one with Emma Mercier. So she had this CSEPS project, and I kind of like came out like, can we collect some audio data? So we're right now kind of doing a bunch of analysis of some of that audio data. So there's an undergrad engineering course. They come into our little lab space. We have a lot of, cameras in the ceilings and things like that. And then got those headset microphones and all the students and talking to them about that during their discussion sections. Okay. So in terms of that PBL project, so we were trying to think about these like sort of larger patterns of the facilitator and the group. So that one's set up where we have groups of about 8 students and a facilitator. And like that's how their whole med school curriculum is set up for the first, I think, 1.5 or 2 years. They're doing these PBL problem-based sessions. It's a kind of a new thing in med education. But these facilitators need feedback and how their facilitation is going. Like they really don't really know about that. And like they might have some expectations, oh, like I'm gonna be talking a lot, but I, don't want to talk too much, and like trying to like figure out the right way to facilitate these. That's hard. So we've been looking at these sort of multi-day patterns. We have a case that lasts for 1 week, which is 3 class periods. And so we're looking to see like kind of what kind of patterns are happening across those 3 case days. And then also trying to think about, we had kind of a pilot study with 3 groups over about 6 weeks. And so some groups had a lot of differences day to day, and others were pretty similar day to day, but looked very different than other groups. So trying to really figure out that way. And it seems like some facilitators, they seem to just like to talk a lot, and are like, okay, maybe you should bring it back just a little bit. And other ones where there's certain days, so like for instance, the Friday day of that week, we expect the students to be doing more talk than the facilitator because they're kind of presenting their ideas. And so if we, for instance, saw that the facilitator was doing a lot of talking on Friday, or even like more than they would on Monday, like that might be a bit of a like little red flag, like, okay, maybe something happened, you need to tell us, but like, just be aware that like you're talking a lot more than we think you probably should be on that particular day, for instance. Okay. And then in terms of other projects, so like I said, we're halfway through this project. It's real world classroom data. So we have this data set was collected as part of someone's dissertation before the project started. So it's sort of a secondary data analysis. It's very, very messy data. As you might imagine, they're mostly high school math classrooms. So we're thinking about kind of 2 different kind of computational approaches mostly. So computer vision and the speech analytics. So in terms of the computer vision, like things you may not have thought about, there's a lot of bad or uneven lighting in classrooms that causes lots of problems. Also, we're using this OpenPose software, which is looking for different like key point detections on students to see like, basically like where is the teacher moving around the room a lot? Are kids moving around? Like, are they like kind of leaned in and like engaged or off on who knows doing what? And so things like the lighting can really be a huge problem with these data sets. But also the kids are sitting at their desks mostly, which means like half of the key points are like cannot be detected. And there's a lot of occlusion with people walking in front of each other and things like that. And if you just have like a 2D view of things, it's really hard for these kind of things to understand, like when people are walking around the room a lot, which, people have seen middle school classrooms like or high school classrooms, there are like a lot of people walking around, and like those algorithms are like not built for that kind of situation, for that scenario. It's just like not the thing that they were meant for. And so a lot of the work we've been doing with that part so far has been around these trying to track people over time. So like understanding like, oh, if we're trying to track the teacher, like how are they walking around the room, and trying to figure out how to do that kind of well. And that team is making some good progress there. And then in terms of the audio data, the team I'm kind of leading, we have other issues. So there's a lot of background noise. The microphones that were used to collect the data are not really meant to be used in that kind of situation. And so like they have little table mics, and it's collecting lots and lots of, they're like trying to be helpful. Like, let's collect all this audio data. Like, no, that's not what happened. Which would have been fine probably, because it was, again, like this data was collected for someone's dissertation, they had this data and they were able to like get what they needed out of it, but what they needed as a qualitative researcher is not the same as the computation algorithm needs to do its work, right? So there's a lot of background noise, and also classrooms in general are really bad acoustically. There's just like tiles everywhere, and it's just like sound bouncing around everywhere, and not great. So our project is really trying to document the ways in which these computational approaches are failing. So that's been really exciting to just like say, oh, this isn't working. Cool, why isn't this working? So we're trying to really do a good job of trying to figure out like where things are working, what situations are occurring, like why is it not working here and it is working over here. And really trying to understand that as much as possible and document all the failures and kind of map out what that failure space looks like so that we can give guidelines to like, okay, if you really care about doing these kinds of things, you want to set up the equipment in this way, you want to do this kind of analysis, and like just hopefully we'll end up with some guidelines for, you know, good data collection in classroom spaces, as well as kind of like what things are not going to work and just kind of be aware of that and okay with that. The other thing I want to kind of end with is talking about agency and data collection a little bit. So one thing I want people to think about is like, if the participants have any agency in when and how their data is being collected. So one example of this is, you know, those headset mics in the middle school classroom. We were initially thinking, okay, like these headset mics are kind of a pain. They're, you know, they're there. They don't love wearing them. There's cords everywhere. Like eventually we'll get rid of them and it'll be like a much easier thing where they'll have a little microphone. They won't even notice it. It'll be fine and it'll be great. And then we're like, well, is that really what we want to do? Maybe it's not. And like trying to think about what that headset mic represented and like what it was, you know, kind of talking to them about. And so we were talking to some teachers and you know, just trying to figure out like what made sense for that space. And so we kind of, you know, settled on this idea of like the headset mics were good for a couple of reasons. One, if a student wanted to not have their data collected, they could just take it off. It was really easy for them to just be like kind of opt out, like, you know what, they need to take a break, they need to like go do something, like they can just easily just take it off. It's really simple for them to just say, not right now. And you know, while they were in the study, they've consented to be part of the study, but like you're thinking about regular classroom kind of data collection, it's not really part of a research study. Like, how does that work? Like, do they ever have agency and like say, no, like not right now? Maybe, you know, trying to think about that. But also the headsets were nice because they signaled to the students like, okay, it's time to put on your collaboration headsets now. And like, they knew that like when they had the headset on, it was time to collaborate and they were time to like talk to each other and kind of like get serious for a little bit where they could like really focus on a thing. And so that was kind of nice. It wasn't something we had thought about early on in the project, but towards the end we're like, maybe these are a good thing. So just kind of want people to think a little bit about what that means and how they could kind of incorporate that into what they're doing. Okay, so finally, just some of the design principles for better data. So working backwards from the claims you want to make, right? So what do you want to say at the end? And then like work backwards so that your data collection strategies are going to be able to provide evidence for that claim later on. Like that's really important. Think about what other data are available in this setting. What is the right data to answer your question rather than just what is the easiest one to collect, right? Those are probably not going to be the same thing. Maybe they are, maybe we'll get lucky. That always happen. You're going to need to find the right partners. So maybe you need to work with people in computer vision, maybe you need to work with people in speech research, maybe whatever it is, like you probably need some other outside expertise. Grain size of data is something I think is really important that we don't talk enough about. And so making decisions about the grain size and like how often things are being collected. It was just my data viz class last week, we were talking about counting, like how do we count things? Like it's actually really important. Like you just made a lot of decisions in how we count things that have repercussions for the analysis later on and like how we understand and contextualize these data. So it's really important to think about that. And also, you know, what are these possible negative impacts on you learners or teachers, and then ways to design more agency into your data collection system. That's really important. Okay, and I think, Doug, my name is Linda, and I'd be happy to answer emails or my Twitter or things like that or questions now. So thank you so much.
Take some questions. Over here so I can see the room and then if you can help
What
me.
did student agency over their data look like in the learning management system context? Like when you mentioned like you're tracking when they were logging in and out of the site, when they were taking quizzes, that sort of thing. Were they aware of what data was being collected there?
That's a great question. I do not think they were, which is not great. So yeah, I think this is one of the things we need to be in general, like more aware and more communicative with their students about like when they're using these different online systems, like what is being collected, like just tell them, be like, okay, like we're tracking this and this and this, like there's no reason not to tell them that, right? Like, well, some people probably argue like, then they're gonna game the system or whatever, like, well, then you have bigger problems instructionally if they're trying to do that. No, for real though, because then they're clearly not taking their learning seriously, and that's like a bigger you problem than the system problem, right?
Were there any, like when the teacher reached out based on, oh, I saw you hadn't logged in a couple weeks.
Yeah.
Were there any surprises or like,
I
did you hear
don't-
any student response around like, oh, how'd you know that?
I did not, but what I will say about that project, we're only involved with that for like a little bit of time, but and so there was multiple messaging things going on with that project in particular. So they were doing all this stuff about like growth mindset and stuff. And so there were like additional like non-math messagings that was happening like regularly throughout the course. So I think if students saw those other messages, they wouldn't be like shocked or anything. I think they kind of understood that like they were trying to do something different with this class and like trying to help them really. And it was extremely successful. It's actually like a really good curriculum for community college students.
Questions?
I wonder if you could say a little more, give some examples about that second design principles. Given your experience, I'm sure you can talk to that.
Yeah, so I mean, I think part of this is like this audio data, right? Like we have, especially in face-to-face situations, there's a lot of other data that's like available in the space that we're not harnessing and we're not thinking about. So it's either, you know, some people do stuff with like eye gaze or positioning. So like people like lean in and like other kinds of nonverbal things, as well as, you know, just how much people are talking. And like, that's a huge part of it. That could be a big thing. I think there's other examples too, but yeah, it's not easy to collect that data, unfortunately, but it could give you a better signal into like what's really going on. Like if you have a conversation or, you know, between two people, like you kind of want to capture the intonation, like the other things that could be going on, as well as like turn taking and like how much people are talking and stuff like that.
Any questions in the Zoom room? Ed? Other questions?
I'm very interested when you talk about the speech analysis for to code the frequency and the duration. So when you look at, so I remember that picture that with different groups.
Yeah.
So when you look at the groups that students have like talking a great amount, but how do you know the quality? Do you look at the quality of their talk?
Yeah, so they were all, we watched the videos, we like humans like sat down and coded all of them for those codes. So we had a coding scheme, we did all the reliability checks and everything. So yeah, they were all, like the video was really helpful to look at that. So I think some people, always had questions like, well, you're just looking at like how much to tell. You're like, no, we're really not. As you can see from that thing, like some of them were talking a lot and like had bad collaboration or talking not very much and still doing well because there were other things going on. And so those codes were sort of a more holistic kind of approach and like look at like how well they were collaborating as a group. Yeah.
I have a question.
Yes.
Cynthia says, yes, I like the right data versus easy data question. How do you know which one is right and better data? Did you have experience not finding the appropriate data in the classroom?
I had a lot of experiences with people sending me data sets. Like, we collected this data, like what kind of analysis? I can't do anything with that, like that's garbage. So because they hadn't really thought about, they're like, oh, we just had this like convenient, like this, like a lot of times it was some kind of learning system, some kind of curriculum online. They're like, we have all this data, and like had so much data. They were so happy they had all this data. And I looked at it, I was like, well, I can't do anything with this because you didn't think about what kind of claims you wanted to make about learning, and you just collected kind of like what web pages people clicked on. Like that's not helpful. And so like I had a lot of experiences like that. And so it's really started thinking about like, okay, we need to start early on. Like you need to have the like analytics kind of person part of this conversation early on. Like planning data collection is really, really important. And that could include designing these online systems as well. So like what data is being logged and when and how, at what frequency, like how often do we want to collect what's happening? And like, you need to really think about all those things as early on as possible, because otherwise you're trying later on to try to munch something out of this data that's there, but it's not the right data, it's the wrong grain size, it's like missing it's not the hover data, it's the click data, right? Those kinds of things. And so, I think that a lot of times that data collection process is kind of like looked over, tried to do it quickly, like, oh, we got really excited, we were like, do this thing, and like, let's just get it out there and collect the data, but we hadn't really clearly thought about the whole pipeline and process that comes from like physically collecting the data, whether it's online or in person, to like doing all the data processing, to doing all the data analysis, to making claims about what was going on in that space. Part of it is like, maybe we don't have the right context. So like we have all this thing, but we don't know what was like going on in that class. Like with the community college things, right? Like we had all this data, but like we didn't know like until we actually talked to the instructors, like some of them just weren't assigning this thing. And that's why it was showing up differently in their data. Like if you don't actually know much about the context, other kinds of physical things or other kind of things, like you're not gonna be able to contextualize that data properly and do the right thing with it. So a lot of it is, it's just more work of having to like understand the context better, understand what's really going on in that space. Yeah.
Well, I may not have listened carefully enough, but when you talked about good collaboration, what was constituting good collaboration?
Yeah, you were listening fine. I didn't explain that fully. So yeah, so I'm trying to remember exactly, but like the coding team basically was like, we were looking for cues that all three members of the team were kind of all collectively working towards the same goal, that they were either talking to each other or making eye contact or doing some kind of thing that was active and like showing that they were all trying to solve the problem together, basically.
So that's connected to the other thing I was wondering about, which is where does the schema come from that says this is what looks like good class participation? Or you mentioned there are kind of models of this is correlated with people who are failing or are going to be failing.
Yeah, so for that math one, so that one was like literally their grades in the course. We had historical data from like previous semesters of that course. And so we were just looking at like all of the data, like how they were interacting with, you know, which resources they're looking at, how often they did the quizzes, how often they passed the quizzes, like did they, if they failed the quiz, did they like try it again immediately, or did they go look at a resource and then go back and try it again, like that kind of behavior. Just like what percentage of the course curriculum they accessed, and then like what their final grade was. And so it was really based on the historical data in that case. Yeah.
Thank you so much,
Yeah,
Cynthia.
thank you.
Early, some information next month. We'll have Tony Brogat coming to give our talk. I think it's November 2nd. I'm imagining it's going to be something about engagement. We haven't gotten titles yet, but and then finishing off this semester will be Kaylani Craig coming from IU. So we have an exciting semester planned, and good to see you all. So thank you again. And lunch is outside. We have sandwiches from Jimmy John's. We were not ready to hand out pizza yet or have people grabbing pizza. Yeah. So
Jimmy John's.
Good job.